Okay, so chemical problem 1 is that the Mr. Freeze can accelerate from rest to a speed of 26 meters per second in 6 seconds, and it asks you to find the average acceleration of the car. Remember, the first thing we got to do is draw a diagram of the situation. And so our situation is we've got Mr. Freeze right there, and it's going really, really fast to the right. We know that its initial velocity is going to be equal to 0, and we know that its final velocity, all the way over here, is going to be equal to 26.0 meters per second. Our change in time is going to be 6.00 seconds. Now that we've done this, we need to quickly sketch both a position versus time graph and a velocity versus time graph. This object speeding up while moving in the positive direction, so our position time graph will look something like that, while our velocity time graph is going to look something like this. We have this. Now we have our givens. We know that our VI is equal to 0 meters per second. My VF is equal to 26.0 meters per second. And my change in time is equal to 6.00 seconds. This is all the information I have, and the first thing I'm trying to find is my acceleration. There's a couple ways I can do this, but the easiest way that I can do this is simply by taking the equation that my velocity final is equal to my initial velocity plus my acceleration times my change in time. I know that I'm trying to solve for my acceleration, so I need to get a by itself, which means I need to subtract both sides by VI and divide both sides by change in t. That's equal to my acceleration. And now I can plug in my numbers that I have. 26.0 minus 0 all over 6.00. I then put this into my calculator, and I come up with 4.33, and because everything has 3 sig figs, that's going to be my answer. So it's going to equal 4.33. My units are going to be meters per second Part 2 of the question, if you go back here, is what distance does it travel in this time? This one I can do multiple ways as well. But the easiest one is probably for us to just use the equation that delta x is equal to 1/2 VI plus VF, close parentheses, times change in time. My delta x is what I'm solving for, so literally it's a matter of just plugging it in. 1/2. My initial velocity is 0. My final velocity is 26.0. And my change in time is 6.00 seconds. And so I need to put this into my calculator. 26 plus 0 times 0.5. That's the first one because you remember order of operations. Times 6. Left with 78. All of these have 3 sig figs, so my answer needs to have 3 sig figs. And so my delta x is equal to 78.0 meters.